Alright, so in this video we're talking about our third and final method of solving a system of equations by elimination. Some people might call it solving by linear combinations. Essentially, if you hear that linear combinations, they're talking about eliminations. They mean the same thing, so don't get confused. Again, if you like the previous two videos, solve by graphing or solve by substitution, that's fine. I'm just trying to provide you with some options, okay? So this video we're focusing on elimination. And like in the previous video, I have some steps listed trying to talk you through how to do this linear combination idea. So what we're going to do is multiply one or both of the equations by a constant to obtain coefficients that have opposite signs. That's where the elimination comes from. We're going to add these two equations together, and hopefully, if we've done it right, one of the variables will eliminate or cancel out. And then we're going to solve for whatever variable remains, and then from there, once we know one of the variables, we can go back in and plug in and solve for the missing variable. So again, that's kind of complicated when you just try to explain it in words, so let's actually do an example. In this particular example, what we're doing is solving the system 2x minus 4y equals 13 and 4x minus 5y equals 8. I have two equations and two variables, so again, I'm either going to have one solution, no solutions, or infinite solutions. Okay, so let's find out. We're focusing on the elimination method. So the elimination method is first, you need to pick what variable do you want to eliminate. I want to eliminate, let's say, the x's. So when I'm done doing all my stuff, the x's should cancel out temporarily. Okay? So to do that, what I need to do is focus on, I have 2x in the top and 4x in the bottom. Well, I need those variables to eliminate. So what I'm going to do is multiply either the top equation or the bottom equation or both equations by some constant to kind of make those coefficients come out to be opposites. So I want to multiply the top equation and the entire top equation, that's important, by -2. The reason why I'm multiplying the top equation by -2 is because when I do that, I get negative 4x plus 8y is equal to negative 26. Again, you have to multiply the entire equation for this to work. If you promise, I'm not wrong. I did not touch the bottom equation. I could have, but I didn't need to for this problem. So I have 4x minus 5y is equal to 8. Now it should be pretty obvious. Our next step says we want to add these two equations together. So I'm going to add these two equations together. So negative 4x and positive 4x, those are opposites. That's what I was talking about. So since they're opposites, when I add them together, they're going to cancel out. X is gone temporarily. Now all I have to worry about is the y. So 8y plus negative 5y is 3y. And negative 26 plus 8. Well, that's a little bit bigger. I'm going to use my calculator, but I believe it should be 18. So let's just do it, double check. And it is negative 18. Hey, if you struggle doing that basic math in your head, use your calculator. I use my calculator sometimes too, just to double check myself. Don't let your ego or your pride get in the way. Anyways, we want to finish solving for y now. We have 3y, which is multiplication, so to undo multiplication, we need to divide both sides by 3. And so we end up with y is equal to negative 6. Great, that's one of our answers. Now, what we want to do is, everywhere we see a y, we want to plug in negative 6. What's nice about the elimination method is we can plug into either the top equation or the bottom equation. It doesn't matter. I'm going to plug into the bottom equation just because I can. If you ever plug into the top equation, that's fine. We should still get the same value of x when we finish though. So I'm going to go back to the original problem. And this time though, everywhere I see a y, I'm going to plug in a negative 6. So again, this is just scratch work. 4x minus 5 times negative 6 is equal to 8. And now I want to clean this up and solve for x as much as I can. So I have 4x plus 30 is equal to 8. I got the 30 by negative 5 times negative 6. Negative negative makes a positive. Now to get x by itself, our first step is getting 30 over here on the right-hand side. So we need to subtract 30 to do that on both sides. So 4x is equal to negative 22. Okay? And now we want to divide by 4 on both sides. Oops. Divide by 4 on both sides. So when we cancel out, we get x equals negative 22 over 4. Let's see if that reduces again. I'm just going to save some time and use my calculator. It's negative 5.5. I'm going to use that as a fraction in the lowest term, so that's negative 11 over 2. So that's my answer. It's all right that I have an answer for a fraction. No big deal. You could write it as a decimal too, as negative 5.5. I prefer fractions, and I would encourage you to stick with fractions. Really and honestly, the only time you should use decimals is if they tell you to round. We want the exact answer, so that's why I'm using the fraction here. That's it for the elimination method, or AKA the linear combination method. Again, make sure you know all three: graphing, substitution, or elimination. But when it comes time to actually do a problem, use whatever method makes you happy. All right, great, thanks.